Okay. Good afternoon. Good afternoon. Next point. Hi. And then welcome back to the chemistry class. Bye. Last recording. Right. In the last class, the basics we have discussed. Aromaticity, preparation, and properties we need to discuss. Aromaticity, preparation, and properties we need to discuss. Let's take the heading aromaticity. A small concept, aromaticity. So here, in order to predict whether a compound is aromatic or non-aromatic, so there are three important conditions. To be a compound to be an aromatic, it should satisfy the three conditions. Number one, the compound must be planar. Number two, it should contain 4n plus 2 pi electrons. And number three, these pi electrons must be in conjugation. Conjugated pi electrons should be present. So, a compound is said to be aromatic. Aromaticity. Benzene is aromatic or non-aromatic? Aromatic compounds. So just I will give some of the compounds, whether it is aromatic or non-aromatic. One more category, anti-aromatics are also there. So just aromaticity. Alkyls 4n plus 2 pi electrons. Alkyls, pronunciation se aao tarah ke name bitradu. Alkyls rules. So here, a compound is said to be aromatic. It should satisfy three conditions. Number one, the compound should contain 4n plus 2 pi electrons. And the second one, it should be planar. It should be planar structure. And the last one, the pi electron should be in conjugate. Conjugation is required. Conjugation. If these three conditions are satisfied, then the compound is said to be aromatic, or else it is non-aromatic. Aromatic or non-aromatic. Let us illustrate these rules or aromaticity concept by taking some examples. Let us illustrate this concept by taking the example. Benzene. Benzene. How many pi electrons are present? This is a planar structure. 3-membered ring, a planar structure. This is also planar structure. One double bond, one plus, one minus, double bond. 4-membered ring, alternative double bond. 5-membered ring, 5-membered, 5-membered ring with plus and minus charge. 6-membered ring, 3-membered, 4, 5, 6, 7-membered. Plus or minus 7-membered. Different compounds are given. Among these, can we classify these compounds into aromatic, anti-aromatic, and non-aromatic? Simple. In order to predict the compound is aromatic if it should satisfy these three conditions. 4n plus 2 pi electron, and all these are planar structures. Planar. Second, and one more is conjugation. That is, alternative single and double bond should be present. Alternative single and double. Look at in this case, in case of benzene, all are almost okay. These are planar compounds. This compound, non-planar compounds. many carbons? 1, 2, 3, 4, 5, 6, 7, 8. Double bond, single, double, single, double, single, double. Alternative double bond, but it is not planar. Non-planar. Now, in case of benzene, first point it is planar. Okay. Second point, conjugation is there or not? Conjugated double bonds. Yes. Second point is okay. Now, how many pi electrons are there? 6 pi electrons. 4n plus 2 rule. 4n rule, 4n plus 2 rule. If the compound which contains, in addition to these two conditions, if it having 4n plus 2, where n is equals to 4n plus 2 pi electrons. Let us give n value 0 to x value. 0. If n value is equal to 0, how many pi? 2. If n value is equals to 1, 6. N value is equals to 2, 10. Next 14, 18, 22, 26, 30, etc. 4 difference. What about the 4n rule? Just 4n pi. N is equal to 0, 1, 4, 8, 12, 16, 20, 24, 28, 32, etc. If the compound, if a planar, cyclic and conjugated compound containing 4n pi electron, then it is said to be anti-aromatic. It is aromatic. This one is aromatic and this is anti-aromatic. If other than these pi electrons, that is said to be non-aromatic. See the first one, benzene, aromatic or non-aromatic? Aromatic. Second one, first point, planar. Conjugation is there or not? Conjugation. Yes. Because there is a plus charge. Resonance what about the resonance? Plus charge. Plus charge. Next, again, resonance will take place in this case. Okay, second point is also satisfied. How many pi electrons are there? Only 2 pi electrons, because one double bond, 2 electrons. So 2 electrons means it is aromatic compounds. Yes, this is also aromatic. Aromatic. Next, yes, planar and conjugation. There is alternative single and double bond conjugation system. Conjugated, delocalized pi electrons are there. Okay, delocalized pi electrons. Next, aromatic or non-aromatic? Non-aromatic. Non-aromatic is particularly anti-aromatic. And why? So how many pi electrons are there? 2 or 4. So this negative charge. This is also involved in the bonding. So when these electrons are involved in this case, it forms one pi bond, and these 2 electrons get shifted on this. So therefore, total 4 electrons are there. 4 electrons means it is anti-aromatic. It is aromatic. This one is anti-aromatic. Next, planar structure, delocalized pi electrons. 4 electrons are there. So therefore, this is also anti-aromatic. Among these two, which one is aromatic? First one is aromatic or second one? First one is aromatic. Second one is aromatic. First one, non-aromatic or anti-aromatic? Anti-aromatic. 2 pi bonds, 4 electrons. So 4 pi electrons are there. Remaining conditions are satisfied. Therefore, it is anti-aromatic, and this one is aromatic because which containing 6 pi electrons. In this case, 6 pi electrons. Here containing 4 pi electrons. This containing 4 pi electrons. It containing 4 pi. This one 2 pi, 6 pi electrons. Next, what about this? 1, 2, 3, 4. 8 electron delocalized. 8 electrons means what it is? Anti-aromatic? No, it is non-aromatic. Reason? Not planar. It is stub-like structure. It is not a planar. So therefore, this is non-aromatic. This one, non-aromatic. Reason? Delocalized pi electrons are not there. Conjugation is not there. If you move to the resonance, So therefore conjugation is not there. Delocalized pi electrons are not there here. So therefore non-aromatic. Non-aromatic. Whereas plus or minus, delocalization is there, cyclic structure. Now check the pi electrons. Aromatic 6. And here it is 8 pi electrons, 6 pi electrons. It is aromatic and it is anti-aromatic. Aromatic and anti-aromatic. What about this? Cyclo octa triene 1, 2, 3, 4. Conjugation, planar, but 8 electrons, anti-aromatic. This is also 8 containing 8 pi, it is anti-aromatic. Anti. So this is also anti-aromatic. Clear concept? Number 1, structure must be planar. It should containing 4n plus 2 delocalized pi electrons. 4n plus 2 electrons plus those are delocalized. That means alternative single double in conjugation in the local. So the compound is said to be aromatic or else non-aromatic. If it contains 4n pi electron, then it is said to be anti. Or else other than these two, it is non-aromatic compound. This is the concept of aromatic. Next is preparations. Examples not portfolio. Simple. Those 3 points. 4n plus 2 pi electrons. Compound must be planar. And other one is conjugated double bond or delocalized pi electrons must be present. Next is preparation and properties. Preparation and properties. Heading preparations of benzene. Computer? Right. Next. Preparations. Heading preparation of benzene. Yes, how many reactions they have given? Preparations. Number 1, preparation of benzene from acetylene. That is cyclic polymerization of acetylene from hexane N-heptane. Next, from benzoic acid or sodium salt of benzoic acid. Next, from phenol, reduction of phenol in the presence of zinc dust. Halogenation, reduction. Yes, so there are no reactions for decarboxylation of sodium salt of carboxylic acid. So 3 reactions. 3 together occur. And preparations of benzene. Preparations. Number 1, from cyclic polymerization of ethyl from phenol from sodium salt of from benzoic acid. Benzoic acid. From benzoic acid. Fourth one, from haloarenes. Just by reduction of haloarenes uses to benzene. Next month of the reaction what was noted? Just I want benzene. Or okay, let's continue. Preparation. The first one from ethyl. From N-heptane, N-hexane, and N-heptane, etc. Right. First one from cyclic polymerization of ethyl. Exactly copy paste chemical properties of alkynes in that cyclic polymerization. So what happens when acetylene undergoing cyclic polymerization when it is passed through a red hot iron tube, which gives benzene. First reaction clear? Repeated. Ethyl alkyne only chemical properties. In benzene, it is preparations. Same reactions. I am repeating. First one, when acetylene CH triple bond CH, when acetylene is passed through a red hot iron tube. Red hot means at high temperature. This gives rise to the product benzene. Second to what is this name? Ethyl. When ethyl is passed through iron tube, red hot iron tube at high temperature, gives rise to benzene. This is one preparation. Just one preparation. In detail, like chemical properties all have growth. Detail avashyakate hai na? Is it required? If want, you can write triple bond CH triple bond CH triple bond CH triple bond CH. So one bond is get shifted between these two carbon atoms simultaneously. These are get shifted and gives benzene ring. Benzene ring. So this is first preparation. Simple. When acetylene is passed through an iron tube at very high temperature, this gives rise to benzene. One reaction is completed. Second reaction from phenol. From phenol. When phenol undergoing reduction in the presence of zinc dust, in the presence of zinc dust, what's it? Zinc. So this is phenol. Phenol. When it is heated with zinc dust, zinc oxide is eliminated. So hydrogen remains there only, and this results in the formation of benzene H plus zinc oxide. Benzene hydrogen ಬರಿಬೇಕಾ ಬರಲಿಲ್ಲ ನಡೆಯುತ್ತಾ ನಡೆಯುತ್ತೆ just understood. So ಈ position ಗೆ hydrogen ಬರಲಿಲ್ಲ ಅಂತ ತೋರಿಸ್ತಾನೆ ಅಷ್ಟೇ. Even though if you are not writing this, it is understood because all the carbon atoms in benzene containing one more hydrogen. So this is the preparations of benzene from phenol. Reduction of phenol uses to benzene. Third one, from sodium salt of benzoic acid. From sodium salt of benzoic acid, COO+. Sodium salt of benzoic acid. This one is sodium salt of benzoic acid. When it is treated with dash, when it is treated with soda lime, what is the composition? NaOH plus calcium oxide. This gives rise to the product. Product is benzene because of decarboxylation. Product is benzene. Sodium salt of benzoic acid gives rise to the product benzene. Benzene. Next. Wording ಬರ್ಕೋರಂಗೆ ಜೊತೆಗೆ complete. Yes. Can you explain this? ಏನಾಗ್ತದೆ reaction ಅಲ್ಲಿ? When sodium salt of benzoic acid is treated with soda lime, gives rise to benzene. That means the reaction self-explanatory equations. Reactions ಬರ್ಕೊಂಡು ಕೆಳಗೆ ಅದನ್ನ ಹೆಸರು ಬರ್ಕೋಬೇಕು ಅಲ್ಲಿಂದ ಈಸಿ ಆಗುತ್ತೆ. Self-explanatory reactions. So here this is the reactant in the presence of this, which gives rise to the product. Next, fourth one. Explain this. X and it is benzene, and this is treated with hydrogen in the presence of nickel, palladium, or platinum, etc. This gives rise to the product H. What is this? What is this? Halobenzene or simply haloarenes. When halobenzene or haloarene undergoing plus hydrogen means what? Reduction of, we can call this reduction. And halobenzene undergoing reduction in the presence of at least nickel or nickel, which gives rise to benzene. You know the product benzene. N-hexane, alkanes chemical properties, cyclization. Check out the alkanes chemical properties, last reaction, alkanes. Alkanes chemical properties not one. N-hexane in the presence of metal oxides is heated, which gives rise to benzene. N-heptane gives rise to toluene. Second,
H is not attached to phenol.
yes.
Reacting product side.
In product side, this is not attached. It is benzene. Is any difference? What is the difference between the first and second compound? If suppose I am writing hydrogen, what is the name of this compound? Benzene. So just one hydrogen is shown in this reaction. If you want, you can else directly you can write the reactions. It is benzene. Yes, this is the preparation. Next, from N-hexane. 6-1. Alkanes chemical properties. Aromatization. Nickel. Reducing agent. Nickel alloy. So when N-hexane, that is CH3, CH2, 4 times CH3, which undergoing aromatization. That is formation of aromatic compound. Aromatization gives rise to benzene in the presence of molybdenum oxide, vanadium oxide, chromic oxide, etc. at high temperature. So this gives aromatization reactions. Here it is repeated aromatization. If it is N-hexane, suppose if it is heptane, what happens? N-hexane. If it is N-heptane, benzene derivatives, that is toluene is produced in this case. So just preparation of benzene is one reaction. N-hexane, not let's say for N-hexane. Benzene. This is the preparations of benzene. Preparations. Next is its properties. Preparation and properties. That's not all the preparation reactions. Preparations. Complete up? Okay, right. Next is properties. Properties. Physical and chemical properties. Yes. Physical properties. Some of the common words, physical properties. First, physical state, solubility, density, melting point, boiling point, color, etc. Color, odor. See, first point, physical properties. Benzene, how many carbon atoms? 6. And it is closed chain. It is not open chain. It is closed. So preferably the lower member, that is up to C6 to C7 or 8, it is in liquid state. Benzene, lower member of the compounds are in liquid state, whereas the higher member are preferably in solids. Lower member are liquid state usually. Previously, what we have written the points in the physical state, C1 to C4, that is lower member of compounds are in gaseous phase. C5 to C17 approximately in liquid, and more than C18 it is solid state. So here lower member, that is up to C8 carbon, up to C8, maximum is C8, that is liquid, and remaining are solids, and remaining more than this they are exist in solid state. First point, physical state. What about its solubility? Can you predict solubility? Like, dissolve like. Benzene is a polar or non-polar? Non-polar. Therefore, it is insoluble in water. Benzene is a non-polar. It is soluble in non-polar solvents. So it is insoluble in water. Solubility. It is insoluble in water. First point. Second point. It is insoluble in water. Insoluble in water. The reason, benzene is a non-polar compound. Polar, non-polar. How differentiate ಮಾಡ್ತಾರೆ? Electronegativity, bonds, suppression of charge check ಮಾಡುವಾಗ benzene is insoluble in water because water is polar solvents. Next, density and melting point, boiling point. Density ಏನಂತ? Density increases with increasing, directly proportional to change, that is length, mass. As the molar mass increases, density increases. Density is directly proportional to molar mass. Melting point, boiling point. Melting point and boiling point is also increases with molar mass. Melting point, boiling point. For isomeric compounds, ortho position, ortho, meta, and para. Among these three, which one is having higher melting and boiling point? Yes, because of most symmetrical structure which having higher melting point and boiling point, compounds of this. So para which having very higher melting point among the isomeric compound, because which having same molecular formula, same molar mass, isomeric. So as the branching increases, melting point, boiling point decreases. Branching increases, melting point, boiling point decreases in isomeric alkenes and alkynes. ಎಷ್ಟು ಬ್ರಾಂಚಿಂಗ್ ಆಗುತ್ತೆ ಅಷ್ಟು ಮೆಲ್ಟಿಂಗ್ ಪಾಯಿಂಟ್ ಬಾಯ್ಲಿಂಗ್ ಪಾಯಿಂಟ್ ಡಿಕ್ರೀಸ್ ಆಗುತ್ತೆ. ಕನ್ಫ್ಯೂಸ್ ಯಾಕೆ ಮತ್ತೆ? ಬ್ರಾಂಚಿಂಗ್ ಇನ್ಕ್ರೀಸಸ್, ಮೆಲ್ಟಿಂಗ್ ಪಾಯಿಂಟ್ ಬಾಯ್ಲಿಂಗ್ ಪಾಯಿಂಟ್ ಡಿಕ್ರೀಸಸ್. ಚೆಕ್ ಮಾಡಿ ನೋಡ್ಕೊಳ್ಳಿ ಪ್ರೀವಿಯಸ್. ಕರೆಕ್ಟ್, ಕನ್ಫರ್ಮ್? yes, done. This is about the physical properties. That depends upon the groups present on this. If it is which having neighboring groups having a tendency to form intramolecular hydrogen bonding. Inter and intramolecular hydrogen bonding. If hydrogen bonding is present, then two molecules are held with a strong force of attraction. So therefore, as the bond strength increases, melting point, boiling point increases. Melting point, boiling point increases with increase in the bond strength. So preferably now size में ಹೇಳ್ಬೇಕಾದ್ರೆ just van der Waals force of attraction increases, melting point, boiling point increases. In addition to that, if you suppose it containing OH group, phenol, OH group. In OH, that oxygen has a tendency to make hydrogen bond with another molecules. So because of that hydrogen bonding, the melting point further it is increased. So this is the concept of physical properties. The next main properties are important properties, chemical properties of benzene. Chemical properties. Let's go to the root heading. Chemical properties. First one is substitution reaction. Electrophilic substitution reaction. Yes. Five reactions: halogenation, nitration, sulfonation, Friedel-Crafts, alkylation, and acylation. So with mechanisms it is given. Next reaction. Addition reactions, addition of hydrogen, addition of halogen, etc. Next. Third reaction what is that? Last movie test close. Electrophilic substitution and addition. Electrophilic substitution reaction, ESR, electrophilic substitution reaction. Five reactions are there. Substitution. Five reactions. One is chlorination, Generally halogenation. In halogenation, fluorination, chlorination, bromination, iodination are the reactivity orders are compound. Next, after this halogenation, nitration, sulfonation, Friedel-Crafts alkylation, acylation. These 5 reactions are again and again it is repeated in the higher class. Class 1. Different chapter math repeat agtaru. Electrophilic substitution reactions. So here the same mechanisms will be followed for higher classes also. Next. So first one is chemical reactions. Heading chemical reactions. First one substitution reaction. Second one addition. Next addition reactions. After that oxidation of its derivatives. Okay. Only 2 reactions. Some addition and substitution reactions. Chemical properties. Number 1, substitution reaction. Substitution reaction. Preferably electrophilic substitution. Electrophilic substitution reaction. Electrophilic substitution reaction. ESR. Electrophilic substitution reactions. So here 5 examples. Number 1, first one is halogenation. Halogenation of benzene. Next one, the halogenation of dash. For the example, halogenation reaction. Second one, nitration, halogenation, nitration, sulfonation. Sulfonation. Fourth one is Friedel-Crafts alkylation and Friedel-Crafts acylation, alkylation and acylation reactions. Friedel-Crafts alkylation and acylation reactions. So 5 reactions. First, I will write the 5 reactions and then I will explain the mechanism for all. Reactions or other. So before going to these mechanisms, I will first explain the mechanisms itself. Mechanism. Halogenation, nitration, sulfonation, Friedel-Crafts alkylation and Friedel-Crafts acylation. So it is an electrophilic substitution reaction. Now an electrophile is going to be substituted by hydrogen. Hydrogen is substituted by an electrophile. See, first I will write the reactions. Number 1, first one is halogenation reaction. Heading halogenation. In this, write down the reaction. One is benzene plus. It is benzene plus X2. X2 is nothing but it is halogen in the presence of FeBr3 Lewis acid, AlCl3, FeBr3, FeCl3, etc. A Lewis acid is used, preferably in dark conditions, not in the presence of sunlight. See the difference between, if suppose the same benzene ring in the presence of an example Br2 or Cl2 in Fe or in a dark condition, dark reaction is possible. The same reaction if it is carried in the presence of CCl4 or in the presence of CCl4 is an addition reaction. In the presence of Lewis acid is a substitution reaction. Yellow reagentable catalyst. Reagents are organic compulsory. So ಯಾವ reagent ಇದೆ ಏನು ಬರುತ್ತೆ ಗೊತ್ತಾಗಲ್ಲ. Halogen in the presence of CCl4. ಅದಕ್ಕೆ ಕೆಲಸ ಏನು? 2 halogens are added across the carbon-carbon double bonds. X2 in the presence of Lewis acid, if it is used, 1 halogen is added or it is substituted in the benzene ring. So one of the hydrogen from benzene is replaced by the halogens. So here in the presence of Lewis acid, so this gives us total 6 hydrogens are available in this case. 1 hydrogen is replaced by halogen. Any 1 hydrogen, you will replace not. So here this gives rise to the product benzene ring 1x group. Halobenzene is the product. plus HX. Byproduct and necessarily ನಿಮಗೆ halogen. Benzene react with halogen in the presence of halogen carriers. Other simply we can call in the presence of Lewis acids. In the presence of Lewis acids gives halobenzene. Halobenzene. Just iron catalyst. In the presence of sunlight and mention ಮಾಡಿದ್ರೆ ಅದು ಬೇರೆ ರಿಯಾಕ್ಷನ್ ಬಂದಿರುತ್ತೆ ಅದೊಂದು ರಿಯಾಕ್ಷನ್ ತೋರಿಸ್ತೀನಿ ನಿಮಗೆ pentolene react with halogen in the presence of sunlight in the absence of sunlight nuclear halogenation side chain halogenation ಅಂತ ಡಿಫರೆನ್ಸ್ ಬಂದ್ಬಿಡುತ್ತೆ ಎಲ್ಲಾಗುತ್ತೆ ಪೊಸಿಷನ್ ರಿಯಾಕ್ಷನ್ಸ್ ಹೇಳ್ತಾನೆ ನಾನು so first this is a halogenation reaction now look at the order of reaction halogenation which halogen is substituted readily ಯಾವ halogen is fast substitute ಆಗುತ್ತೆ iodine fast ಆಗುತ್ತಾ fluorine fast ಆಗುತ್ತಾ ಯಾಕೆ iodine ಯಾಕೆ ಆಗೋದಿಲ್ಲ why is not larger in size good reason because of its size the order of reactivity follows F2 is more reactive than Cl2 which is more reactive than Br2 and the least is I2 but preferably in the presence of I2 reactions ಮಾಡಬೇಕಂದ್ರೆ in the presence of oxidizing agent is required the reason if I2 is used the byproduct is HI it is a reducing agent which revert back the product so therefore the produced HI in the presence of HNO3 if it is used so this oxidizes this product to I2 HI is converted into I2 therefore the product which cannot be reverted back so therefore iodination takes place in the presence of oxidizing agent so this is the order of reactivity order of halogen second reaction is nitration reaction same and benzene react with concentrated HFO3 in the presence of concentrated sulfuric acid so simply we can call mixture of concentrated HNO3 and concentrated sulfuric acid is known as this mixture is known as nitrating mixture and in this case this gives us to the product nitrobenzene so one of the hydrogen from benzene is replaced by NO2 group this is nitrobenzene is produced nitrobenzene here it is halobenzene nitrobenzene is produced third reaction is sulfonation reaction when benzene is reacting with concentrated sulfuric acid fuming sulfuric acid H2S2O7 it is called fuming sulfuric acid fuming sulfuric acid it is H2SO4 it containing SO3 H2SO4 in bracket SO3 fuming sulfuric acid so in this case this gives rise to the product benzene sulfonic acid SO3H benzene sulfonic acid benzene sulfonic acid these three reactions halogenation nitration sulfonation ಮುಗಿದವರು yes ಏನಾಗ್ತದೆ halogenation say now the case benzene if benzene is reacted with halogen in the presence of Lewis acid gives halobenzene if it is treated with nitrating mixture nitrobenzene fuming sulfuric acid benzene sulfonic acid if the same benzene is treated with two more reactions fourth reaction Friedel-Crafts alkylation FC reactions Friedel-Crafts alkylation FC alkylation means what addition of alkyl when benzene is treated with alkylation and acylation 4 and 5 reaction okay You can write in one or you can write in separate. Separate benzene plus first reaction product of alkylation. When benzene plus it is treated with alkyl halide in the presence of FeCl3 or AlCl3 or FeBr3, that is Lewis acid. This gives rise to the product alkyl benzene. So one of the hydrogen is replaced by R group. It is alkyl benzene. Alkyl benzene. R group is substituted. If the same benzene reacting with RCOX, acid chloride, acyl chloride, RCOX, then this COR group will be added to the benzene. Benzene with COR, acyl benzene, acetone, acyl benzene. Common name is acyl benzene. Acyl benzene is produced. Acyl benzene. So these are the 5 reactions. In these reactions, a nucleophile is substituted in the benzene. That is, yes, RCOX, acyl chloride, or acid chloride, acyl halide, X is halide, halogens. Acyl group is RCO group is nothing but it is acyl group. Acyl halide or simply acid halide. So this RCO group is substituted in the benzene. RCO group is substituted. So these are the 5 reactions. 5 reactions are, and all these 5 reactions takes place through a common mechanism. All cases mechanisms common. I will explain the mechanisms. Note down these 5 reactions. Done. Now let's check the mechanism. The electrophilic substitution reactions, which involves the mechanism of this ESR reactions, ESR involves 3 steps. Mechanisms experiment. First note on the reactions. Hold up. The same reaction. Lewis acid. FeCl3, AlCl3, FeBr3, etc. Friedel-Crafts alkylation and acylation. Electrophilic substitution reactions. 5 reactions. Yes. Addition reaction. Direct influences. Reaction 1 beta. Right. Let's see the mechanism of ESR, electrophilic substitution reaction. So the mechanism of electrophilic substitution reactions, which involves 3 steps. Mechanism. Mechanism of electrophilic substitution reaction. Mechanism of electrophilic substitution reaction. It involves 3 steps. First, step 1. Step 1, generation of electrophile, attack of electrophile, and lastly, last step is deprotonation. Deprotonation. It involves 3 steps. First one is generation of electrophile. Generation of electrophile. generation of electrophile. So preferably electrophile. For example, in case of halogenation plus X2, nitration, sulfonation, Friedel-Crafts alkylation, acylation. In all these reactions, first step involves the generation of electrophile. For example, benzene is reacting with some reagents. So first, electrophile. This is the reaction. X2, NO2. There is nitrating mixture, sulfonation, alkylation, acylation. Now, general example, general reaction. So this which produces E plus the negative part. Electrophile means what? Let us take one example in case of halogenation reaction. Because all the 5 reactions involve same mechanisms, only this step is different because different examples were taken. In first case, halogenation, benzene is reacting with Cl2 or halogen X2 in the presence of AlCl3, Lewis acid, AlCl3, FeCl3, FePr, etc. Lewis acid. So you can say the Lewis acid are the electron carriers. So first it coordinate with one of the Cl minus ion and it forms AlCl4 minus. AlCl4 minus. AlCl3 is the deficient of 2 electrons, which takes 2 electrons from this and which carries these electrons. And remaining part is Cl plus. This is in case of halogenation. Halogenation first reaction. Second, if it is a nitration reaction, nitrating mixture, the nitrating mixture is what? HNO3 plus H2SO4. So usually from this H2SO4, it split up to give H plus HSO4 minus HSO4 minus. This H plus HNO3 H plus, immediate molecule H plus, this H plus which combines with this 2OH minus and water is liberated and NO2 plus plus H2O plus H2SO4. So from nitrating mixture, this is the remaining terms H2SO4 plus HNO3. So from this H2SO4, H2SO4, one H plus from sulfuric acid and OH from HNO3 which combines water and remaining HSO3 minus H2SO4 HSO4 minus and NO2 plus. Electrophile yavudaralli NO2 plus is electrophile. This is the second reaction. Third, sulfonation. Sulfonation is H2SO4. 2 molecules of H2SO4, 1 water molecules will be eliminated. From 2 molecules, 1 water molecule is removed and this gives less to. From 2 molecules, 1 water molecules will be eliminated, gives less to H2SO4 plus SO3. This is the electrophile. Here it do not contain any charge. H plus SO3 plus illa. ಬೇರೆ ಕೇಸಲ್ಲಿ ಎಲ್ಲ ಪ್ಲಸ್ ಇದೆ SO3 plus ಬರಂಗಿಲ್ಲ. 2 molecules of sulfuric acid, 1 water molecule is eliminated and gives H2SO4 plus SO3. Now, others we can write in this place. So from 2 molecules of sulfuric acid, we can write H2SO4 H3O plus SO3 plus HSO4 minus. So SO3 is the electrophile in sulfonation reaction. Friedel-Crafts alkylation and acylation. Friedel-Crafts alkylation layer by you. We have taken RX in the presence of AlCl3 or AlX3, particularly chloride, alkyl chloride. Benzene is reacting with this in the presence of Lewis acid. Lewis acid can say halogen carrier. So this will carry this halogen and gives R plus AlCl4. Yes, AlCl4 minus. Acylation reaction RCOCl in the presence of AlCl3. Lewis acid is equal same, which carries the halogen gives RC double bond O plus. The carbon male plus under there. This carbon male heading. Carbon carrying plus charge plus AlCl4 minus. This is the first step. Allow one example very. Next step is common. Second step is common. First step is the first step. Other second step is common. Let us indicate these electrophiles. Electrophiles Cl, NO2, SO3, R plus, RCO plus. These are the electrophiles. Let us use the terms E plus for all the electrophiles. Second step, attack of electrophile on benzene. First step, in a particular reaction, an electrophile is generated. 5 reactions there were. How the reaction is the reaction the compound. First step, electrophile is generated. Second step, attack of step number 2. Step 2, attack of electrophile on benzene ring. Benzene. An electrophile is attacking on the benzene ring. See how it attacks. So this is the benzene. Benzene plus E plus. In a chlorination reaction, it is Cl plus. In nitration reaction, NO2 plus. In sulfonation, SO3. Friedel-Crafts alkylation, R plus. Acylation, RCO plus. So first, electrophile attack on the benzene ring. So double bond ilide, unshift ಆಗ್ತಾ ಇದೆ. ಯಾವ ಕಡೆ ಶಿಫ್ಟ್ ಆಗುತ್ತೆ ಇದೀಗ? So this gives rise to the product benzene. Look at the diagram carefully. Shifting of electrons will take place. These two remains as it is. If suppose this pi electron is shifted on the carbon number 1, let us call this as a carbon 1 and 2. If it is shifted on the first carbon, then electrophile will attack on the first carbon atom itself, because shifting of electron takes place towards the carbon where electrophile is going to attack. So here, suppose if electrophile is attacked in this position, then the plus charge will be found here. Adi HL bantu already munchene ide, yellow torsilla, idu torsilla in direct time. So already, so electrophile is attacked here, and this is the plus charge. Now this will undergoing resonance. Plus charge illa carbon already satisfied its valency, tetravalency, where it is deficient, because initially in between these two positions double bond was present. Now the double bond is get shifted, so therefore it is electron deficient. It getting the plus charge. Remember, these are hydrogens. Okay, you can write plus charge here also, no problem. So in this, if this bond is involved, if electrophile is attacking E plus, then you get the plus charge. Yell double bond break agide check ಮಾಡ್ಕೋ. ಆ position plus ಬರುತ್ತೆ because deficient of electron. So now displace resonance structure. Is it complete? Step 2. Electrophile attack on benzene ring. This gives rise to an intermediate structure which undergoing a resonance stabilized E, and this will be plus. Now it involves the resonance. this structure. Resonance of transfer. To stabilize this carbon cation, the adjacent position pi bond will be shifted. E pi bond will shift as there. So what will be the charge? Next, resonating structure, benzene ring. This bond is remains as it is in its position. Hydrogen and electrophile as it is. Now this bond gets shifted in this position. So therefore plus charge will be on the adjacent carbon. Next carbon. Next step. Can you write the structure? Yes, okay. This pi bond is shifted here. Benzene ring, double bond. This is the plus charge. And so this can be written as in general. These are the resonating structures. Resonating structure. And the last step, step 3, deprotonation. Deprotonation means what? Deprotonation. Removal of the proton, that is just H plus is removed. Now this is the resonating structure. Now the plus charge is here, plus charge, double bond. This in the presence of AlCl4 minus in case of halogenation, again byproduct negative part. In the presence of that negative part, this hydrogen will be eliminated. So this bond is get shifted back, and this gives rise to the product benzene in one position electrophile plus HCl plus AlCl3. Catalyst remains as it is AlCl3. So one of the hydrogen from the benzene which eliminated along with the halogens, and one electrophile is substituted in the benzene. So this is electrophilic substituted product. Electrophilic substituted product. Benzene melgade the R hydrogen, any one of the hydrogen is substituted or replaced by an electrophile E. This is the mechanism, and this mechanism is the same for all the 5 reactions. The mechanism is same. Check rearrangement, resonating structures. First step, generation of electrophile. Second, the electrophile is attacked on the benzene ring, and in the last step, the hydrogen is removed. Hydrogen, particularly proton H plus. Hydrogen removed on the H2 consider just protonation, deprotonation. One proton will be eliminated. So this is about the mechanism of substitution reactions with examples. Remaining one addition reaction and directive influences of the groups we will discuss in the next class along with your doubts.